When buried at reservoir depths, rocks are subject to internal and external stress. The internal stress results from the pressure of fluids in rock pores. External stresses are exerted by the weight of the overburden, overlying formations, and any accompanying tectonic stresses. Overburden pressures vary from area to area depending on factors such as depth, nature of the structure, consolidation of the formation, and possibly the geologic age and history of the rocks. The most important consideration is the depth of the formation, and a typical value of overburden pressure is approximately 0.023 megapascals per meter of depth. The weight of the overburden simply applies to a compressive force to the reservoir. The pressure in the rock pore spaces does not normally approach the overburden pressure. A typical pore pressure, commonly referred to as the reservoir pressure, is approximately 0.01 megapascals per meter of depth, assuming that the reservoir is sufficiently consolidated, so the overburden pressure is not transmitted to the fluids in the pore spaces. Before production, internal pressure pore pressure and external pressure overburden pressure, confining pressure in reservoirs, maintain balance with each other. Once the reservoir is disturbed by drilling and consequently production, the pressure balance is broken. The pressure difference between an overburden and internal pore pressure is referred to as the effective overburden pressure. During pressure depletion, oil reservoir production, the initial pore pressure decreases, and the effective overburden pressure increases since the overburden load remains constant. This increase in pressure difference causes the following effects. A. The bulk volume of the reservoir rock is reduced. B. Sand grains constituting the rock expand. C. Fluids within the pore spaces expand. The first two volume changes tend to reduce the pore space of the rock. Both the decrease in pore volume and the expansion of fluids will continuously drive fluids flowing out from pores. Moreover, the output of fluids from the reservoirs will lead to a further decline in pore pressure and the release of the elastic energies of rock and fluids. The elastic energy of a rock is an exhibition of rock compressibility. The elastic energies from the rock and fluids are thus the major drive energies of oil production in an undersaturated oil reservoir, especially in the initial stage of reservoir production. If you want to learn more about the compressibility of reservoir rocks, you can do so in my book, Economics of Petroleum Reservoirs, which is published on Amazon. Check it out at the link in the description. Please take a second to hit the like button, hit the subscribe button, and do not forget to also hit the notification bell. Thank you for watching, and goodbye.